Hello friends, this is Dr. Antoine Nyungeko, your coach in data analysis using R2. In this video, I'm going to show you how you can perform exploratory factor analysis using R2. I'm going to use data which is in package 11, and I will show you step by step how you can conduct exploratory factor analysis. You need some libraries for checking. For instance, this one will help you to make a descriptive analysis. This one will help you to identify outliers in your variables. You must have these libraries. If you don't have these libraries, you have to install them by clicking on tools, then install packages, and you write the name of the package you want to install, and then you click install. Okay friends, let's select the data and then make a standardization of my data or normalization of my data. You must have this package. Let's run this package, then let's select the data and scour them. Now I can show you the first element of my selected data set. You can see the first element. Now we have these values for each variable. Now this function here allows you to perform descriptive analysis. This one. You can see the result of your descriptive analysis. Then you can just make analyze dimension to know how many observations you have. This function dimension dim allows you to see the dimension. Now you see we have 301 observations with 9 variables. We continue. Then we can we can analyze if you have missing values with this function. This one, if you want to analyze missing values, use this function. Now, as you can see here, we do not have any missing value. If you have the missing value, you can calculate the sum of missing value by using this function. Okay. Now, the next thing that you can see is to analyze whether we have sufficient correlation, or you can analyze if there is highly correlated variables. If there is highly correlated variables, it is a problem, because you can have what we call communality, when you have highly correlated variables. Now we can analyze if we have highly correlated variables. Now you can see here, friends, the correlation matrix here. You see we do not have higher correlation, which is greater by 0.9. Now, as you can see here, correlation is not very high. Next thing we can do, we can check whether our variable there is outliers by using this function, and you can check also for normality, because for instance here the observation number 43 is considered as outliers. This one also is considered as outlier, this one also, and so on and so forth. Now you can check for all variables. This is to check normality using Shapiro test. Look friends, now here you see this variable is normally distributed. Let's see this one. This one is not normally distributed. Let's check this one. Also, it is not normally distributed, and this will affect the way I will try to analyze the number of factors. Now you can check for all variables, no problem. You can use also this command mardia from package piece. Now, as you can see here, friends, there are some observations which are outliers. Normally, if our variables were normally distributed, all observations would be aligned on this line, this one, but you see some observation which deviate from this line. This is for normality testing. Now we can just try to find average intercorrelation, which ranges between 0.2 to 0.4. This is the range of intercorrelation, average intercorrelation. Now let's see if you can have value which is, you can see here friends, the result is 0.26, which is between 0.20 to 0.40. Now the next thing to do is to calculate inter-item reliability using these comments. Yes, as you can see here, item discrimination indices should be above 0.1. When it is between 0.1 and 0.2, it is considered as fair, but when it is greater than 0.2 or minus 0.3, it is considered as good. Let's run this comment to see the results. Now you can see here, as you can see, item discrimination. You can see here the results. Now we continue. We can calculate before we make our factorization. We need to check Kaiser-Menet-Oakland test to see when it is greater than 0.6. Let's run these comments. This is one of the steps you have to perform before you make factorization. You see here we have 0.65, which is, sorry, here we have 0.75, which is greater than 0.6 here. We can also check for homogeneity of variance by using Bartlett test. Here the null hypothesis is that samples have equal variance. We run these tests. You see the p-value is greater than 5%, is 1. We do not reject the null hypothesis. Now we can make factorization because all indices are met. Now you can use this comment to perform to identify the number of factors. Let's learn all these comments and use also a plot. You will see the number of factors. Okay, now you see we have 3 factors. Let's use other methods. Let's clean here. When I use Spearman correlation, because I was using Pearson correlation, let's use this one, Spearman correlation, to identify the number of factors. Because I use Spearman because I found that data are not normally distributed. That's why I try to see when I use non-parametric tests whether I have the same number of factors. You can see here we have 3. Now we can also use another way of making factorization, finding the maximum number of factors by using this comment. Let's use this one, and you see the message here indicating the number of factors. Here you can see here friends, the number of factors is 3. Let's use another method, minimum residual. You can to see also the number of factors. Let's learn this. You will see also the message indicating the number of factors. Let's run these comments. You see here we have the number of factors is 3. Now we can also use maximum likelihood. This is another method you can use. This one. You can see here we have also number of factors is 3. Now we can make factorization as we found that number of factors is 3. We are going to use Promax, which is an oblique rotation method that begins with varimax rotation and then uses kappa to raise the power of the loadings. Loadings is nothing but is the correlation to the factors. We let run these comments to make factorization. Now we can print the results. I can show you the results. this using this comment. Now you can see here the result here. Now if you have your data, you just need to replace your data. You can see the loadings on factors, but you can see there are some these variables are loading on two factors, but what you have to consider is where we have the maximum the higher level, the maximum value of loadings. For instance, this value you see here, friends, the maximum or the great value is on these factors 3. For the variable number 2, you see where we have the highest loading is here, ML3, and so on. Now we continue. Now, as we have performed our model, we can calculate what we call communality, which is the variance explained by our factors. Let's run this comment to analyze communalities. Now you can see our communalities, which must be greater than 5%. Now, after running this comment, we can just print the result. We consider cutoff of 0.4 for printing our results. Now you can see here finally what we have as loadings. You see we have loadings which are greater than 0.4 as our cutoff. You can see this variable 1 and 1, 2, 3 are on one factor. This variable 4, 5, 6 are on one factor. This one on this one are loading on this one, and 7, 8, 9 are loading on 2, this one. Okay, now when you finish to do this, you can also calculate what we call alpha coefficient alpha of Cronbach coefficient alpha. Cronbach coefficient alpha by using, you have to select these, for instance, because these variables were loading on the same factor, and you need to calculate the coefficient alpha. Then you select this one, but because this data set was retrieved on this library lab1, I cannot select them individually. That's why when you see here, when I try to select them, I cannot have to select them. You see now there are some error message, and if it is the data set you imported in R, you can easily select this variable and you calculate the alpha Cronbach. Now you can make visualization of your model. Let's run this comment. Now you can see, friends, how you do visualization of your model. You can see these values you see here. These values you see here are loadings. These values are loadings. Now this is the end of the analysis of exploratory factor analysis. I think this can help you if you want to develop a new measurement instrument. This is how you can perform exploratory factor analysis. But when you have a great number of data sets, you have to cut them, separate them in training and testing data. The next step is to make what we call confirmatory factor analysis to test whether the factors the model you have developed or the factors you have identified is correct when you make confirmatory factor analysis on a data set which was not used during exploratory factor analysis. I think this video will help you to analyze your factor analysis, and if you found this video helpful, you can subscribe to our channel, you can share our video and subscribe and like it. Thank you very much for watching this video. For next video, bye.